Now that we have a basic understandings of these primitives of music, notes, rests, an idea of rhythm, how notation works, and so on, it's time to look at some of the computational tools that we will be using in this course. And in particular, a library that I have been developing for now maybe 5 or 6 years that is called Music Network. That actually is a container for many different modules that deal with aspects of music and complexity. And we will be using this library extensively, and you will also have information on how to install it in the section where I explain all the technical requirements. So Music Network is a very large library, but for now we are actually only interested in using a very limited set of functions, of objects of this library that are the ones that are relating on what I call the composing tools. And basically these are 3 main objects. They are called note, rest, and not sec. And they can be imported in your notebooks using these commands that you see on the screen. These 3 objects deal with the 3 main components of music representation. We start from rest, that is a very simple class of this library. That basically is an object that generates a rest with a given duration. And the duration is the only parameter that this class accepts. It accepts a duration as a floating point, so you can give 0.25 if you want to give a duration of 1/4, or even write 1/4, and that will be understood as a rest that lasts for a quarter note. The class has only one method that allows you to stretch the duration by a factor. So you can use this to multiply the duration by that factor, and this will return a rest with the resulting duration. All this is explained and discussed and described in the notebook that is associated with this unit. The next class that I want to discuss is note. That is actually the object that is most, it has more attributes and keywords of all of these 3, and is clearly central to the definition of objects in a computational sense. So the class note has 6 attributes. And some of these attributes are keyword arguments, so they help us specify that note in terms of pitch and duration and volume, amplitude of the sound. So the keyword arguments are value, that is the pitch number of the note, in integer notation modulo 12. So these are integer values from 0 to 11, as we have introduced in this integer notation for pitch. The second one is octave. So we now have the pitch number that is absolute, as we have said before, we discovered before. Now we have to place this pitch within 1 octave, and so if you think about the keyboard, we have to decide which range of the keyboard we place that pitch. And so octave is a number that typically goes from 0 to 7. And the octave number 5 is the central octave of the piano. So the central C in the keyboard is a pitch 0, octave 5. Now, note also allows us to use a different kind of encoding of pitch in terms of numbers. This is what is given by the MIDI standard that I mentioned earlier, but I never really defined. So MIDI, or Musical Instrument Digital Interface, is a protocol that was invented in the early 80s to allow computers and digital instruments to communicate with each other through messages. And some of these messages are actually note messages. So these messages carry musical information. They can tell to a synthesizer, for instance, to play a given note for a given time and then stop playing it. If you look in this graph on the right, you see a mapping of the keyboard, of the piano keyboard in terms of MIDI number. MIDI number go from 21 to 108, from the very left to the very right of the keyboard. And in this chart, you also see the assignment in terms of pitch names and octaves, and the corresponding frequency of the fundamental vibration, vibration of that particular pitch. So Note accepts not only the integer 0 to 11 plus octave format, but accepts also a MIDI number, so a number between 21 and 108, to identify a particular pitch in a particular octave. Duration is another parameter, dur, that is the note value, how long a note will play for, and as in rest is a floating point number that is either, for instance, for a quarter note 0.24, or can be actually written as 1/4. Volume is another of these MIDI parameters that can be interpreted by the note class. MIDI volume has value that go from 0 to 127, and this is a range of numbers that is typical of the MIDI protocol for many other kind of messages, but in this case we use it for volume. So 127 will be very, very loud, and 0 will be basically silence. Finally, the last keyword is verbose. That is just a keyword, an attribute to basically display or write down on output the parameters of the note object. Note has also 4 methods that corresponds basically to the operations that we have introduced in the previous unit, the operations that transform sequences of note into other sequences. So these are transposition, inversion, stretch duration, and harmonize. So transposition is basically a method that allows us to transpose that note to a particular height relative for a particular interval relative to the original note. Inversion inverts the note through the operation of a rotation, basically, as we introduced in the previous unit. Stretch dur does exactly the same thing that it does in the rest object, the rest class. It either elongates or shrinks the duration of the note by a particular factor. And harmonize is a more complex method that basically builds a chord that is on that particular note according to a given scale. We will come back to these concepts of chords and scales very much in some of the future units where we discuss more about the geometrical properties of this integer space modulo 12 that are our notes and their representation. There is also another way of passing information to the note object. This will become more clear in the notebook associated with this unit. Actually, information can be passed as a string of characters that is formatted in a way that has the note name, the duration, and the octave where the note should be placed. And this is a conventional way of indicating this information through specific formats that I will explain more in the practical session. The last object that I want to discuss in this unit is note sec. That is an object that allows us to combine notes together to create a sequence. So here we can have a list of objects like notes and rests that are interpreted by this note sec object as a continuous flow of pitches or rests. So basically a musical phrase. This is it behaves like a Python list, so you can add to it with it or append or insert to it with the insert method. And you can use directly nodes and rest objects in this nodesec class. You can use the shorthand notation using a string. You can actually read from a file the full notation of the sequence and import it into a nodesec object. So it's a very versatile list that we will be using a lot to manipulate our musical objects. And again, I will demonstrate this in the practical session on the notebook. So nodesec has many methods that correspond to music operations that we talked about. So as in the node case where we can transpose a node, here we can transpose the whole sequence of nodes. So we have a transposition method that returns a new sequence transposed by a given interval. We can retrograde the sequence, so we can have the sequence played from right to left rather than left to right. We can actually specify even more the transposition method by saying we want to transpose starting with this note rather than just generically on the sequence. We can invert the sequence, so we can look at the inversion as one of the operations that we can do on the sequence directly. And we again can do the inversion, moving it along different pitches vertically with the inversion that starts with a particular note. We can rotate the sequence. We can stretch the duration of the sequence, again, as we note a rest just by a factor, so that we have a longer sequence or a shorter sequence using the same relative ratio of durations. We can stretch the interval by a given factor, so I can have a sequence and then that is composed of different intervals, and if I stretch that intervals, I have like that the sequence has wider intervals or smaller intervals. So these are all manipulations that any composer would do for creating new musical material based on, say, a motif or something like this. And again, the last method is like in note, there is a harmonization method, the harmonize, that again returns a series of chords built on a particular interval on the pitches of the sequence.